All right, so I guess I'll get started right now. And hi, everybody. My name is Anuj Vidodkar. I'm currently the president of the UC Merced Game Development Club. Let me share my screen really quick. Here we go. I'm currently the. Let me just get this started. I'm the president of the Game Development Club as well as the programming chair, and welcome to our Godot Beginners Workshop. It'll take place from 12 to 1 today, and I hope that you guys learn more about this really, actually very cool engine that's used for small 2D games. You can use it in lieu of Unity if you don't have enough time to work with a bigger engine. So, a little bit about who we are as a club. The Game Development Club is a club focused on assisting students in their game development journey. Some of you might know the fact that there's not exactly a lot to support student game developers at UC Merced. There was like one CS class and a Spark class. However, there's no official program and there is a demand for game development. We appeal to a variety of disciplines, with our main chairs being the visual arts chair, the writing chair, the music chair, and me, the programming chair. We have a variety of channels on our Discord that are focused on the various subjects, such as visual arts, writing, music, and programming. And we hope that to see you there. We're part of the Student Game Developers Alliance, or SGDA for short, which is a group consisting of game developers from across right now the state of California, including UC Irvine and other universities that have game development programs as a part of their university. And we are a member school of them. So if there are game jams or events that are taking place at those organizations or universities, then Merced students are welcome to join in and watch those. There are many cool examples, such as speaking with the developers of Outer Wilds, Mobius Digital, and it's a very cool organization. We are a growing organization. We were started 3 years ago during my freshman year of 2018, and we hope to fill the void of game development, that's not at UC Merced, as well as help get anybody into game development or help people who are already into game development be more adept and know more about the subject, or just work with like-minded people on projects. You don't have to have any experience to be a part of us. You can be starting from scratch, or you can have even published a game. We'd love to have you as a part of the club if you're interested. We're people who like making games as much as we do playing them. This slide is a little bit small, I apologize. Our meeting structure consists of our general meetings, where we have workshops focused on the various aspects of game development. These workshops are the bulk of the first semester. The main game engines we focus on are Unity, coded in C#, Unreal, which is coded in C++ and also has a visual coding aspect to it, Godot, which is the main focus of this meeting, and uses a Python-based script called a GD script, and Twine, which is a narrative-based engine written primarily in HTML. From time to time, we host social trips, such as trips to Fresno while we were in person, and games of Among Us while online, because obviously it's much harder to go to Fresno during the social distancing semester or year as a whole. We have a variety of events, such as hosting collabs with other clubs. We recently had a collaboration with Theta Tau, and right now we're having, in a way, a collaboration with the HackMerced. We also participate in game jams, and we're hoping to host one this summer. We were going to participate in the Global Game Jam, however, things didn't end up planning out. But with SGDA, we were able to host one on kind of a macro scale. A game jam is like a hackathon, where the end goal is to make a game within the time allotted. Some game jams can range in time from 48 hours, such as HackMerced, I believe, or a weekend long, long and short, to even a week. I think that the game that we're going to be going over as a part of this workshop, I had a week to do. Our main meetings are on Zoom, with the club as a whole existing on Discord. So announcements, meeting with other people, chatting with other members, all that is in the Discord. I will drop the link as an invite after this workshop if you guys are interested. So I'm going to see if we can watch this video. Audio can be a little bit weird with screen sharing on Zoom. So let me know if you guys can't hear it. can you guys hear? Oop, can you guys hear it right now? Or is
I don't hear the audio, Nuj.
Okay, that's fine. In that case, I'll just drop this link in the group chat.
I was gonna say there's on your share setting, there's a setting to share audio. Unless
Awesome.
you'd rather prefer that.
Let's see how. Let me. Found it. There we go.
In this
Can you hear
video,
it now?
you're going to learn what the
Yes,
GoDot
I can hear it.
is
Awesome.
and what it can do for you. We'll talk about its pros and cons so you know if it's a good fit for you. Finally, I'll give you some free resources to get started with it. Let's jump right in. GoDot is a free and open source, general 2D and 3D game engine. It's a program that allows you to create games or even applications that you can then release on desktop and mobile platforms. You can also make console games with it, although you need strong programming skills or a developer who will port your game for you. A general game engine means that it's packed with features to help people create all kinds of games. You can use it to create an homage to Star Fox like Exodiac, a 2D action-adventure game like Dolphin, a 3D tower defense like TaleQuest, or a beautiful side-scrolling action game like Primal Light. The limits are mostly your skills. Let's now look at the program. GoDot comes with a complete editor in which you can design scenes. A scene can be a character, a weapon, an entire level, or your game's main menu, for example. You can do everything with them, including what other engines call nested prefabs. Scenes are trees of nodes. In GoDot, nodes are building blocks of your game. Let's take the character we just saw as an example. It's composed of a physics body node, a sprite node, a camera node, an animation player node. Hopefully you can tell what each does from the name. GoDot comes with an extensive library of these base nodes that you can compose and combine to create more powerful ones. And that's the core of the tool from a user's perspective. 2D, 3D, UI, you do most things with these nodes in written code, of course. Talking about code, you have two main gameplay programming languages at your disposal. GDScript, GoDot's simple domain-specific language, or C#, a popular programming language. If you're a beginner, we recommend you to start with GDScript, that's the simpler of the two. Also note that to use C# in GoDot, you need to download the engine's special Mono edition. On top of these two languages, you can also use C and C++ to write high-performance game code without recompiling the engine using GDNative. And there's the visual programming language, VisualScript. It works, but the interface lacks some refinement to be productive at the moment. Let's talk about some of GoDot's more prominent pros and cons. This is a subjective list based on my experience. I'll start with limitations or things that can get in the way right now with GoDot 3.2. Some specific editors like the tile map or that node-based interface lack maturity and can be a bit unintuitive or get in the way at times. While 3D is pretty easy in GoDot, the user experience is way behind an engine like Unreal. Level editing and animation tools aren't fantastic at the moment. For now though, you can use Blender 3D instead to do all that. GoDot can import levels designed in Blender directly. There is no market for add-ons and assets. There are still few of them overall, and you get limited support. GoDot has a free asset library, and you can find some decent tools there. Still, we're missing something like the Blender market, where creators can get some financial support and maybe donate some of their sales to GoDot. Now, here are the aspects I like the most about it. First, there are tons of features for 2D, and this side of the editor keeps getting better. It's really mature at this point. GoDot being free and open source software means that you can access the source code, learn from it, and as a professional, you can hire people to fix bugs or add features. We're seeing companies do that more and more. Its domain-specific language, GDScript, has a lightweight syntax, leading to code that's short and easy to read overall. Add-on development is terrific. GoDot's editor is implemented in the GoDot engine, so you can extend it with the same code you use in your games. You can also run any gameplay code in the editor with its tool mode feature. You can get started fast. GoDot is lightweight, it's just a 40 MB download for the full editor with no install required. Starting your game is also pretty fast with short compile times. And as it's free and open source software, you also get a lot of people from all around the world fixing bugs and making improvements from which you benefit. With over 1,000 contributors and counting, it's growing fast. Now, Godot is completely free. It just takes a few seconds to download. Well, with my internet, more like a few minutes. But you should try it out to see if you like it. And to do so, here are some great resources. We wrote 2 curated guides with only free educational resources for beginners and professional developers respectively. Here are also 3 tutorial series to get you started. On GD Quest, we have a 5 hours free course, Make Your First.
I guess I'll stop from there because we're going to be going over a lot of this information right now.
In this video, you're going to learn what the Godot...
Whoops, there we go. Let me check the chat really quick. Perfect. So this is kind of more or less what was talked about in the video. Godot is a free open source game engine. It's very useful for quick 2D games. This HackMerced is a fairly short hackathon in the context of making a game. So it's a useful alternative because of the fact that it's so lightweight. You're able to learn it and pick it up really quickly. And I personally like it for game jams, which, like I said, are like hackathons, but for games, just because of the fact that it's very easy to pick up and use. It will be in our video, or in this workshop, we're primarily going to be going through the basics of the engine, through a deep dive into a project I worked on last summer, summer of 2020, for a week-long game jam. I used the language GD script for that, and that's how we're going to be going through this. So first of all, as I said, you can download the Godot engine from this website. It's godotengine.org. I will put the link in the chat. Let's see. See if we can find the chat first. Perfect. So feel free to download it from here. And I guess just give me I guess I'll give you guys a couple of minutes to download it. While we're waiting for that download, I will go through kind of what the engine looks like when you start it up, and everything fun like that. So if I search my computer, we can see that I already have Godot. So I can hit enter, and this is what it's going to start up and look like. There's a console that runs. You don't need to worry too much about the console as long as it doesn't cause any huge issues, but there will be a console that accompanies you as you use Godot. And you can see that there are two tabs over here. This tab, which is called Projects. Projects is where anything you've made and worked on will be. And there's also, this is a very interesting feature, Templates. So if you click on this, then it's loading. It could take a second. Here we go. There are a variety of different templates that are already available that are really great for kind of getting you into kind of showing you what the engine can do overall. As an example, I have this 2D platformer as a demo. So if I click on it, then it will load it up. There we go. It'll give you kind of a macro level, huge overview of what Godot is. I would recommend not using this as a learning tool because obviously it is there's so much going on here. But you can kind of see a lot of what Godot, you can see just an example of what you can do with it. So let's exit the editor and relaunch Godot so that we can go to the project itself. Is anybody having issues with the download right now? Seeing nobody with any issues, I'll get into the meat and potatoes of this workshop. So this is the project that I worked on last summer and what we're going to be going over. So I'll double click it, and you can see this is what the inspector will look like. If we scroll out over here, then this is what the inspector, ignoring all of this, will look like when you initially launch. This is what it'll look like when you initially launch something with Godot. It will be kind of a 2D axis, it'll start off in 3D, but if you click on 3D, then you can see the fact that it automatically switches between 3D and 2D. I would recommend personally using Godot for its 2D engine because, as the video mentioned, it's very flexible, very well developed. For 3D and anything beyond, you're probably going to want to use Unity or Unreal. However, not every game has to be 3D. This is kind of what a full project will look like. This is just one scene. This is the title screen. So if I click on start the game, it'll start the game. If I click on credits, it'll jump to the credits. And if I click quit, it will quit. So let's run it really quick. You can see that there's music already. So if I hit start the game, it starts the game and it moves on to the next scene. Let's look at some of the code that makes this possible. If you look over here, this is where your scene manager is. This will be everything that is within your screen. So you can see the canvas layer, that's the UI. The parallax background is a type of background that you can use, and you can see that it has a sky texture. I downloaded all of these assets and put them into a variety of folders, like over here. So you can see it's fairly easy to, if I want to make a new folder, then I can just right click, new folder, test folder. And voila, you can see it created over here at the bottom. When using Godot, I would recommend creating a lot of different folders for each of the different things that you want. For example, I have a music folder that contains all of the music. All of the scripts are located inside of this scripts folder. It got a little bit clunky just because of the way that I did cutscenes in this game. However, that's kind of just that's what it looks like overall. There's world assets, which is the way that I constructed the world. And yeah, so let's look at if you click on this button, it'll say open script, and you can see the fact that this is a basic example of what GD script looks like. As you can see, it is based off of Python, and you can tell that just from the syntax. What this will do is change the scene to, and then it'll have where in the local directory the next scene is located. So if I click on,
Anuj, we had a question in the chat.
Yes, my apologies.
No worries. Someone asked if they're supposed to download the standard version or the mono version.
You're going to want to be downloading the standard version. The mono version is for if you want to use C# with Godot. However, we'll be using GD script, so the standard version will be good enough. If you do get very interested in the Godot engine and want to use C#, then definitely go for the mono version. But for now, we'll just be going for standard. So you can see that we changed the scene into res, which is the top folder, scenes, which is the folder that I've currently selected. The file system is over here, and then game.tscn. This is what scenes are saved as. So each different level, for lack of a better word, is saved as a scene in Godot, and that's a tscn file. So if I double click on game.tscn, it's going to switch to the scene tab. And you can see the fact that the original title screen doesn't go away. It's just now there's a different tab. So if I want to make a new scene, then I can just make this. And then you can see, well, if I go, this is effectively looking at just the code right now. So if I can create a 2D scene, let me do that again just so that you guys can see what I did. So if I hit plus button and then I click on create root node 2D scene, this is the basics of what you're going to get. You can drag things on. As an example, if I drag the fruits onto this, you can see there it is. The fruits are located over here. And that's where you're going to be starting. And if I want to save it, I can save it as test scene.tscn, and then I can save it over here. unless, one important thing to note, if you don't link to the scene, as an example over here, if you don't link to the scene at any point, that scene will never show up. If I let's say this is the button that, or let's go for the credits. Let's say that I delete this. Let me check the chat. Let's say that I delete this. Now, what it's supposed to do is it's supposed to take you to the credits. However, right now, what it does is nothing. I'm clicking it, you can see that it's reacting, but it's not taking me to the credits like it's supposed to. This is because of the fact that I need to link it to where the scene is. And if I click this and I hit credits, it goes to the credits. There we go. Linking to scenes is very important because you can put a lot of work into your actual game, into each of the levels, but if you don't link to it, it's entirely possible that the player will never see it because they'll never be able to access it. Let's go into the game itself. So this is kind of what the player will see initially, but let's scroll out to see. This is what the entirety of the game world looks like. It doesn't look too big, but you can see all the various objects. It should have been perhaps a bit better in my creation of them or my management of them in the scene. However, this is similar to what you saw with the title screen, where there's the control. What this blue dot means is the fact that it's a node. Specifically, the type is node 2D. There's node 3D for obviously anything if you're trying to make a 3D game. And there's also, as you can see over here, user interface. User interface will show up on top of everything else, and we'll be going over it a little bit with the cutscenes, which are all of these everything over here. Let me see if I can find it. Here they are. We'll be going over, because all of the cutscenes should be in the same place. They should look the same, and there should never be any elements on top of them. That's kind of what the user interface does. It immediately goes to the top layer so that the player will always see that first. Let's check the chat. Nothing. So let's look at what the player script looks like right now. There's a lot here, but it's not. But let's go through it one by one to kind of unpack it. So what this enumerator does at the beginning of the script is it specifies the states that the player can be in. Each state is effectively just what the title implies. It's a state. It will, once you go into the actual movement and operation of the player character, which is in this physics process, tab, then you're going to be using a switch statement, or in this case, a match statement, which is effectively the same thing, and doing different things depending on what state the player is in. As an example, let's look at the normal state, which is when the player is just moving around in the world, versus the cutscene state. Both of these are enumerated over here, so we don't have to define them anywhere else. They're already defined up at the top of the script. You can see there's a lot going on in normal. There's the moving left and right, moving up and down in the context of 2D. But with cutscene, it just plays different animations. And we'll go a little bit into animations. We'll be going into animations a little bit. If I got rid of this this enumerator, then if I started the game, you can see that I have a little bit of an issue. You can see the fact that the game, I have this error. The identifier cutscene isn't declared in the current scope. That's, if I bring it back, it'll end up working again. Let me close the game really quick. Here we go. Now I've started the game again, and because the enum is back, because cutscene is defined over here, it's able to run this code. Now let's go a little bit more into kind of what you'll be doing with the player character. This function, physics process, is effectively what you'll be using to move around the player. there's this little underscore means the fact that it's going to be running all the time. And yeah, this delta will come in handy when we're going over movement because of frame rate. I'll get into that in a bit. So let's say that the player is moving around. That's what the normal state is. So we are able to get the input vector. The input vector is going to be what's defined as the input vector is going to be how we move the player around. So left, right, up, down, depending on what keys are being pressed by the user. We're setting it to vector 2.0 initially, just because we don't want the player to be moving in some random direction initially. One really cool thing that Godot does is it has these built-in functions with input where you see this input.get action strength UI right. What that means is in the UI, they already have predefined certain keys, those keys being W, A, S, and D, up, down, left, right, for movement. And that's what, and how hard you're pushing down on those keys, or in the case of if you're using a controller, how far you're pushing the stick right is automatically calculated, and not automatically, but it's calculated, and you're able to use that instead of using a key code specifically. It makes the code a lot more easily translated into various control schemes. As an example, if I get my controller, and I will let's see, let me hit space. I can move around using the controller instead of just the W, A, S, and D keys. It's actually a very powerful engine, or a very powerful tool that you can use. So you can see the fact that I'm subtracting everything from the right to the left because it operates on a Cartesian coordinate system where everything to the right, everything going right is positive. Any negative values means that it's going left with velocity. And yeah. Now here's one cool thing that I'm doing with the player. If I go to this scene manager and I click on, where's the player? Here's the player. You can when you create something new in this scene. So as an example, let's say I want to make a kinetic body 2D. Kinetic body 2D is essentially what you're going to want to use for the player, because kinetic body is something that can move and be affected by physics. So if I want to create that, then I'll just use the player as an example. But if I go to the player and I look at the player's everything, all of these items over here, I hit the plus button when I'm selecting the player itself. I hit the plus button, and what this does is it adds a child node. What a child node does is it is automatically connected, and it will automatically move, react, and respond with the player in mind. Some nodes, some objects like kinetic body 2Ds, I mentioned earlier the fact that you need to make a kinetic body 2D in order to make a player that moves, need certain children nodes in order to function. The player, as an example, needs the collision shape 2D in order for it to collide. It also needs a sprite in order for it to show up at all. So that's one of the things that you're going to want to keep in mind. It's not object-oriented programming. It doesn't have to go into like OOP concepts such as inheritance. However, you are going to want to think, if you're running into an error with one of your nodes, then check whether or not you need to add a child node in order for it to work. So let's go for the camera 2D. All scenes essentially start off, or no, that's more Unity, but what this camera 2D does is because of the fact that it's a child node of the player, whenever the player moves, the camera is also going to move. All of this UI, the background, the sky, all of that moves with the player, so we don't have to worry about moving it with our own code. It's attached to the player through being a child, so it will automatically be handled. let's look at that, what that looks like in practice. There we go. So if I hit space, then you can see the fact that there's dialogue over here. I'll go into that system a bit in a few. Let me stop sharing the music because there we go. So if I hit space, now you can see as I move around, the background is moving around too. I don't need to worry about it, like about me accidentally seeing all of this gray space. Because of the fact that it's attached to the player, it'll be moving too. So now you can see a little bit of animation with the player. One of the benefits of using a game engine over raw code is the fact that you're able to handle animation a lot easier than if you were to just code by yourself. Actually, let me check the chat. Okay, you're able to kind of like make animations and stuff a lot easier. So if I look at the sprite of my character, and if I double click on it, you can see, or if I go to player related stuff and I click on when you walk in.png, that's my that's the name of my sprite. You can see the fact that this isn't technically animated. This is just like a bunch of different walking animations, but it's not officially animated. That's because this is what's called a sprite sheet. A sprite sheet is commonly used in pixel art or just open or indie art because of the fact that it's easy to make the illusion of movement by moving through this sprite sheet. There are two different types of ways to animate a player. The first is through a sprite and an animation player, which is what we did in the case of the. Oh no, each sprite has a animation attached to it. There's also animated sprites, which are kind of a different thing. However, we'll go into that in a few. Let's see. You can see over here, I flipped this horizontally because of the fact that I want it to be facing a certain direction. But if I wanted the player to be facing the opposite direction, I could simply hit this button, and you can see it does a little dance because you're flipping the script literally. And if we go to our code, you can see the fact that you would see the fact that there's normally if you want to kind of adjust for a player facing the left direction versus facing the right direction, you could flip their sprite horizontally in order for them to face the opposite direction. I didn't do that here because of the way that the animation player works. However, yeah, so this is one of the ways that Godot can handle animation. Let's look at a skeleton. I believe that for skeletons, I had an animated sprite for skeletons. So with these characters specifically, I have a variety of different animation styles. So you can see that it's centered, which means the fact that you don't have to worry about any XY transformations over here. And the animation style is default. You want to start your animation should generally start at frame 0, just because naturally speaking, frame 0 is where it begins. And let's look at over here. There are three different images that have been loaded into this sprite. And I got that by essentially cutting the image that I used for the skeleton. And let's see if I can. I don't exactly remember how I got this, but in being an animation player, Godot is able to kind of go through and animate this automatically by just going from frame 0 to frame 1 to frame 2, and not really you don't have to worry about that if you're using an animated sprite. For attacking, you can see that there's a similar thing where there are five different animation sprites, or 5 different frames for the attack, and you can actually change the speed to make it either faster or slower. frames per second is effectively how many times is it going to be going through this. So right now, the attacking animation is at 10 frames per second, and there are 6 frames. So you're going to, because it's 0 based, that means that it's going to be going through 10 divided by, it's going to be going through 10 divided by 6 animations per second. And if we look at what the skeleton is doing, 1, 2, 3, 4, 1, 2. You can see that animation in effect, and it's kind of walking toward the player. And that's kind of the basics of how animation works. I'll be linking what I used specifically for this game, the tutorial that I used, in the chat, just because I think it'll also be useful. But yeah, let's go back to the player code really quick. And let's look at the health UI, because the health UI, you can see by the fact that this there's a little scroll over here, it has a script attached to it. This is going through I have the heart UI that is I have my heart UI. I think that's in player related stuff, and it's defined over here. As soon as the game starts, I set the amount of hearts that the player has to 4, and then it displays. And let's see, what else can I do? Now let me go over kind of interaction with other objects. So in my game, you saw when I click on a skeleton, what it's supposed to do is it's supposed to kind of freeze up. It's supposed to stop. So what I did was, if I go to the script for the skeleton also has a variety of states. You can see over here, there's cutscene, where it stands completely still in the direction of the player, or in the direction that it was facing originally. Idle, which is when the player is nearby it, but isn't able to be seen. I'll go over that in a bit. Wander, where the skeleton is just wandering in place. Chase, where the skeleton goes towards the player. And die, which is when the skeleton falls off of a cliff, it will die, because it will fall off the cliff. If we look at Chase, then we can see I have this thing called var player equals player detection zone dot player. Now, what is a player detection zone? If we go to the skeleton, we can see that there's a box. There's this thing called an area 2D by the skeleton, which is you can see this little circle over here. What this does is it checks. It's an invisible kind of circle that surrounds the skeleton of a predefined radius. You can make it bigger, smaller. Let's see. If the player or their hitbox, which you can see attached to which you can see over. If the player's hitbox, you can see this over here, this little thing called collision shape 2D, is inside of this sphere, then it'll know that the player is within its range. Now, how this works is you're linking the collision of the player to this So if I click each of these collision shapes, each of these objects has this thing called node. And if I make sure that I have this right. Here we go. You can see that there's these in the node tag. There's this thing called signals over here. A signal only activates if whatever causes the signal turns out to be true. As an example, over here, we have damage taken, which is a signal that I defined in, there's damage taken, which is a signal that I defined. If that's true, then it calls this function on health UI damage. So I can see in the health UI, there is a, here we go. On player damage taken, whenever the player is in the hitbox range of the enemy, it's going to call this through the signal. It's going to call this function, which simulates the player taking damage. Signals are very important in Godot, and the reason why there's a lot of clutter in the game right now is because all of the cutscenes have a signal. Let me see if we can find the cutscenes. Here they are. You can see that all these cutscenes have these, this area 2D has this property called body shape enter. What that means is that any sort of body has entered I was talking about this earlier with the detection zone. Any sort of body has entered this area, and this function has a parameter which defines, okay, what is the name of this body? What is the type of it? And you can use this information as with the skeleton. You can use this information of let me find the player detection zone. You can use this information to track whether or not objects are interacting, whether or not things are being entered or exited. Signals are a very powerful tool that you're able to use in a lot of places, and that's kind of what I was able to use in order to make sure, hey, the player is within this range, so now the skeleton can chase the player. And also another instance of where I used it was, if I go over here, a cutscene plays. There's a little invisible box over here. If I scroll out and go over here, there's this little invisible box that you can't really go past. You can't ignore it, because if you try and run into these two objects, you won't be able to pass them. So the player has to run into this, and as soon as the player does, the cutscene will play. And once the cutscene is over, let's go to cutscene 2. Once the cutscene is over, that little collision zone will delete itself. This one over here will delete itself. So now it will delete itself and set the player back to a normal moving position. And that's how signals work. They check for any sort of change in a state based off of these little functions, and depending on what you tell the signal to do, whenever those changes happen, it'll execute that. So you can see this emit signal, cutscene started. When I emit this signal, let's go to the player. When I emit this signal, you can see the fact that I set the state of the player to cutscene so that the player can't move, and I'm able to accommodate for whatever happens based off of this completely unrelated object. You can see that player is nowhere near cutscene. It's not controlling it, and yeah, that's kind of overall what I did for this project. I also attached music through a music player. You guys could probably hear it a bit. I turned it off because it kind of got very grating, I felt, but you can see the music. When you enter a dialog box, it'll play. It has a similar signal architecture that can be used. One thing about Godot is the fact that because of how lightweight it is And because of how surprisingly big music files can get, it can be, your music files can end up being the biggest thing in your project. If that's the case, you don't have to worry. That's just, it shouldn't impede on the loading times or anything of the game, but that is something to keep in mind. Music will be a surprisingly big part of your game. And what was mentioned earlier was the fact that Godot is open source. What comes in mind with that is the fact that there are a lot of people that are working with Godot for game jams on their own little projects, and they're able to push out kind of features or things that you might want, to happen in your game, and you're able to kind of use them and facilitate them in your own way, because that's the nature of open source. As an example, I had to have a credit sequence in my game, but it was Thursday, the game jam was ending on Friday, and I didn't really have much time to work on it. So I tried to see if there was any sort of credits, and lo and behold, I'll open this anyway. Somebody had kind of already, somebody had already made a credit scene. And if I Googled Godot credits, you can see that there's on Reddit, and I pulled from this repository on GitHub, and I was able to use that as my basis and use it in my game. The community of the Godot engine is very friendly, and I highly recommend, if you guys are interested in using it, engaging with them, watching the tutorials and messing around. There wasn't really a tutorial on how to make it so that a enemy stops or how to push things around using mouse clicks. But it was through experimentation and just messing around that I was messing around with code that was already there, like with the physics, that I was able to get this game working in time for the game jam. And one last thing that I want to go over is kind of the Godot script, the language itself, just because there is a documentation. This is primarily what I used during the game jam when I was having trouble. I looked for, let's say that I wanted to look for vectors in Godot script, or GD script as it's called. See the fact that this shows you, this documentation page is actually really cool because it has both GD script, the Python-based script that I used in my project, and C#, or the C# library, which I believe somebody earlier was talking about, Ismail was talking about the standard version versus the mono version. If you want to use C# and you want to use the mono version, you have code that's right here for it. And this documentation is useful. I would recommend going through it. And yeah, we're running a little bit early just because I don't really, I guess I'll open the field now for any questions that you guys have, any sort of, yes, of course. Let me get the documentation. Here you go. You can see you can search. If I want to look for, let's just go for vectors again because it's a very vector kind of day. Let's see. Vector 2 is specifically what you're going to be using a lot if you're going for 2D, you're going to be using vector 2s a lot. If you're going for 3D, you'll be using vector 3s a lot. As such, if you guys haven't taken vector calculus or linear algebra yet, I highly recommend it. It'll be really useful for just game development in general. But you can go through this, go through and check out what these functions. Unfortunately, there's not examples per se, but the description that Godot has is fairly solid. If you're confused, then you can just kind of implement it, mess around with it, and see what works, what doesn't for your own projects. Let me see if I can get. There we go. Are there any more questions? If there are no questions, then I can link. What I can do is I can link a. Oh, thank you, MJ. I can link the. Let me stop sharing my screen. The tutorial that I used during the game jam itself. That was an action RPG tutorial, top down, and I can link that in the group chat in the Zoom call. Let me do that right now, actually. But that's kind of how I learned Godot in like a week's time, and yeah, I hope that you guys got something out of this. I hope that this was a fun time, and hopefully you guys can now see the fact that there are more engines than just Unity or any of the popular ones that you see. You can do lots with all sorts of engines. Found it. There we go. Absolutely, it is 100% okay for you to ask me questions. I'll be a lot better about answering them. I'll be a lot better about answering them in the future. I apologize for this if it was unclear to anybody. However, Godot is kind of one of those engines that is one of those engines that's very user friendly. You can learn a lot by just experimenting, by messing around. And I wanted to show you guys the fact that you don't need to even like have much experience with the engine itself to make something cool or something that you're proud of. It's a really friendly engine. The Game Development Club, I will drop the Discord link. I just searched for games on my computer like a kid. I'll drop the Discord link in the group chat. Tomorrow, or rather today, 12 hours from now, actually, we'll be having a workshop on 2D animation hosted by our visual arts chair. And yeah, we'll be pinging people. We've moved workshops to being every 2 weeks this semester because of the fact that just because we know that people are busy, and we want people to have time to work on school, and because Zoom University has been assigning us a lot more work than normal. And yeah, let me drop the link in the group chat really quick. Here you go. We're working on uploading our old workshop recordings to our YouTube channel so that everybody can see them even if they weren't here. So stay tuned for that. And I see that some people are entering the waiting room, and yeah, I'd like to thank HackMerced for letting us host this workshop, and thank you guys for all attending, and I hope that you had fun with this workshop.